There are thousands of different cultures around the world, each one with its own beautiful, fascinating, unique expression of what it means to be human. I truly mean that. Wherever you're from, wherever you're watching this, there is something really special about your culture. I believe that to my core. Every person, every nation, absolutely everybody has their own story to tell. It's just what makes history and archaeology so endlessly interesting. Despite all of our differences, though, there's one story which is shared by absolutely everyone: our evolution. Today I want to discuss what we know, but more importantly, what we don't know about the evolution of you. We're going to take a look at the last common ancestor of us and our closest relatives, Neanderthals and Denisovans. We're going to discuss the evidence for our African evolution before moving on to when we left that region, burst onto the world like a invasive species, and the contradictory evidence that really runs right through the heart of our ideas. It should be well good. It should be well interesting. Big thumbs up. Before I start the video, I do have to give a massive thanks to boneclones.com for providing me with this wide array of hominin skulls that you see before you. I've been using boneclones.com since August 24th, 2019, when I made a video on Paranthropus here. If you've seen any of my videos on human evolution, all the skulls have come from boneclones.com. The reason I buy from them is because these are exact replicas of specific fossils that they found. These aren't just facsimiles. These don't just approximately look like a Neanderthal. This is an exact replica of a Neanderthal skull, an exact replica of a Homo erectus skull. And I really love that attention to detail. That's the attention to detail I try to bring with the information in my videos, and so that's the attention to detail I like in the props that I use for these videos. If you're interested in human evolution, I know you're probably interested in what they sell. I would probably own Paranthropus even if I didn't make these videos, because it was learning about them that really sparked my interest in human evolution and prehistory, and realistically it changed the course of my life. I love having a visual memento of that. I love being able to look Paranthropus boisei in the face every day and see my evolutionary history in the flesh, not in the flesh. These aren't real. But I love being able to see that. I just truly love owning these things. They're so interesting to me. And everyone who comes into my house always asks about the skulls. It's just a cool as hell thing to own. So if that tickles your interest a little bit, I suspect it might, head on over to boneclones.com. There's a link in the pinned comment, link in the description. Use promo code Stefan for $20 off. And yeah, big shout out to Boneclones for providing me these skulls to make this video as cool as possible. Boop. Usually when we talk about a last common ancestor, we're talking about the very earliest hominins, before even the Australopiths, the last common ancestor of us and chimpanzees. However, today, as we're really hyper-focusing on the evolution of Homo sapiens, you and me, we're focusing on the last common ancestor of us and our closest relatives, Neanderthals and Denisovans. Who were they? When did they live? Where did they live? These are all fantastic questions that, to put it frankly, we don't have the answer to. Homo erectus was probably the first hominin to leave Africa at around 1.8 million years ago, and this left scattered populations of archaic humans across Africa, Asia, and Europe. Each one going about their lives, evolving, adapting to their particular climate, their particular circumstances, but also periodically meeting, boinking, swapping genes, swapping ideas. Trying to pinpoint our direct ancestor, untangling them from this really complicated web of relationships, is naturally an extremely difficult thing to do. Genetic studies of 5 Neanderthal remains from Belgium, France, Croatia, and Russia have shown that the last common ancestor lived at least 530,000 years ago. But that's just the minimum time. It could have been as long as 700,000 to 800,000, maybe even 1 million years ago, who knows? So we have this roughly 300,000 year period, maybe even longer, when they could have lived. But exactly who it was is not known. This time period is known as the muddle in the middle because before it we had Homo erectus, after it we have Neanderthals, Homo sapiens, Denisovans, but between these two groups of archaic humans, it's just an absolute mess, and we just have a very difficult time understanding the relationships between the fossils that we have found. And unfortunately as well, we haven't actually found that many fossils from this key time period, so it's really hard to answer these big questions when we're just dealing with a few specimens. One key puzzle in this whole debate has been the site of Cima de los Huesos, the Pit of Bones, fantastic name, in Atapuerca, sort of north-central Spain. 430,000 years ago, this region was home to a group of hominins who were living a really classic Paleolithic lifestyle. They were almost certainly living in their family groups, hunting large game like rhinos and horses with primitive wooden spears, and perhaps deliberately bringing their dead to this cave. There's not much evidence of occupation at the Cima. It doesn't really look like anyone was living there. We also don't see that much evidence of carnivore activity. And yet, 28 hominins were deposited there. It's possible that these archaic humans, these ancient hominins, were deliberately bringing their dead to this particular spot, which raises so many interesting questions about their intelligence and their society and how they lived together and how they loved each other, maybe. It's really absolutely a fascinating place. These remains have been given the title Homo Heidelbergensis, which is a notoriously difficult hominin species to define, because we have this muddle in the middle where we aren't sure of the relationships between the hominins. Many fossils have been given the title Homo Heidelbergensis, but whether they truly are all the same species and deserve to be grouped together is a matter of huge debate. Was this group of hominins our common ancestor, though? It seems not. Genetic tests revealed that they were early or proto-Neanderthals, after the split between us and Neanderthals, and firmly on their side of our family tree. To be fair, some anthropologists had predicted this based on the similarities between Neanderthal and the skulls from Atapuerca, but it is always obviously fantastic to get that genetic confirmation and to be able to really accurately place them on our evolutionary tree. So, as interesting as they are not a direct ancestor of Homo sapiens. They were not the common ancestor of us and Neanderthals. Let's stay in Atapuerca, but go further back in time to around 850,000 years ago. In 1994, archaeologists discovered the remains of several people, mainly children, who seemingly had been the victims of cannibalism. What can I say? Life was hard in the Paleolithic. Sometimes your ancestors probably had to eat children. That's just the way it went back in the day. These remains have been given the title Homo Antecessor, or Pioneer Man, and the best preserved of them is called the Child of Grandolina. This child was about 10 years old when they seemingly became someone's lunch, and the remains have attracted a lot of attention because of the flatness of the face. One of the key features that anthropologists and archaeologists look for in a fossil to determine whether it's a Homo sapien is this flat face placed directly under the skull. And as you can see, this child of Grandolina, their face is very flat compared to earlier hominins like Homo erectus and even later hominins like Homo heidelbergensis. It seems flatter, like ours. So was this child a direct ancestor of ours, very distant ancestor of ours? Well, again, it seems not. Getting DNA out of a fossil that is 850,000 years old is exceptionally difficult. But new scientific techniques analyze individual proteins which survive better in the archaeological record. Proteins on their own, of course, cannot give us as much information as DNA. So please bear in mind that this interpretation of the results could change dramatically in the future if we improve our technology. But proteins can give us clues to ancestry, and it seems that Homo Antecessor was perhaps a sister group of our last common ancestor, living around that same time, a very close relative, but not our direct ancestor, not the common ancestor, not an early example of the Homo sapiens lineage. The child of Grandolina really illustrates a difficult problem that anthropologists have. Just because a specimen might share many of the same physical features as us, it does not mean that they are our direct ancestor. Evolution spins a really complicated web. So as it stands, none of the remains from Atapuerca are on our Homo sapiens lineage or are the last common ancestor of us and Neanderthals. This is basically the situation across the entire world. Anthropologists have been able to exclude some examples and determine who is not our direct ancestor, but finding that common ancestor, finding those really early Homo sapiens, has eluded us. We still have not found them yet. Considering what we're going to discuss later about the origins of our species in Africa, it is very likely that the common ancestor of us and Neanderthals lived there. But the past being so complicated, we do have to keep an open mind that the common ancestor of us, Neanderthals and Denisovans, could have lived in Eurasia. After all, that is where our two closest relatives lived and evolved. So it's not unreasonable at all to think that our common ancestor might have lived somewhere in Western Asia, maybe even in South Asia, India. Our understanding of this time period in India is not great. We have a lot of tools, but so far no human remains from this very early time period. So we have to keep an open mind that they could have lived in India, perhaps. So anthropologists are keeping an open mind, but nevertheless, Africa, for sure, has a special place in our evolution. Wherever our ancestors lived before 300,000 years ago, it's abundantly clear that since that time, Africa has been the beating heart of our evolution. This is confirmed not only by the fossil record, but also overwhelmingly by genetics. There are key features of our anatomy that anthropologists look for when trying to determine whether a fossil is a Homo sapiens or not. As I mentioned earlier, we have a small, flat face. This face should sit directly under our brain case. We have a really distinctive chin, and we have this really round skull. Globular is the technical term. Globby, globby, glob, glob. Now, of course, we have to bear in mind that there is a lot of variation in how modern humans appear. And this variation extends deep into the Paleolithic, probably even more variation, honestly. So these aren't necessarily hard and fast rules, but these are the features that could indicate that a fossil is a Homo sapiens. The earliest fossils that we could describe as potentially being a Homo sapien, an archaic form of Homo sapien, come from Jebel Uhud in Morocco and date to around 300,000 years ago. So far, 5 individuals have been excavated, and as you can see, they do have this small, flat face directly under the brain case, but this skull is not globular. It's egg-shaped. It's much similar to a Neanderthal, much more similar to Homo Heidelbergensis. Because of the shape of this skull, we can't consider them modern humans, modern Homo sapiens, but they have enough features that we could consider them perhaps archaic Homo sapiens, a very early ancestor of ours. Over on the other side of Africa from Herto, Ethiopia, the owner of this skull lived around 160,000 years ago, and as you can see, it's very round, very globular, but has these absolutely chonking brow ridges, really thick, really pronounced, and that's a very archaic feature, you could say, in our species. As you can see from these two examples, humans in Africa during this Middle Paleolithic exhibit a real mosaic of features. The evolution into our modern form, anatomically modern humans, seems to have been a really slow process that has taken hundreds of thousands of years. This mosaic of features continues for a long time in the archaeological record. A skull from Omo in Ethiopia is very round, very modern looking, but dates to 190,000 years old. Skulls from Kafsa in Israel date to around 120 to 90,000 years old, and again are quite modern. I know Israel is not in Africa, we're going to get to that, don't worry. Yet a skull from Iwo Elera in Nigeria has a much more archaic form, like Jebel Ehud has this egg-shaped brain case, but is as recent as roughly 13,000 years old. That's roughly when this person lived. This complicated picture of different alleged Homo sapiens with a variety of features is made all the more complicated by the fact that we know that other distinct, archaic forms of humans lived in Africa at around the same time. Homo naledi lived around 236 to 335,000 years ago, and seemingly is a much smaller form of hominin. We also have this cabway skull, which is considered a Homo Heidelbergensis, and has really archaic features, dates to only 300,000 years old as well. How all these different groups of hominins interacted and what role they played in our evolution, in the evolution of Homo sapiens, is not known. There is some genetic evidence that Homo sapiens interbred with an archaic human around 124,000 years ago in Africa, but it's a very recent study, and the implications of this result are not well understood. Is the skull from Iwo Eleru a late survivor of one of these archaic forms of human, or is it just that Homo sapiens in this region retained some archaic features much longer than anywhere else? It's really hard to answer this question because we just have one skull with no genetic tests. So we have absolutely no idea of the context that Iwo Eleru lived in, the context that they evolved in. The skull from Nigeria is an interesting outlier, though. In general, what we see in the archaeological record is a clear progression from egghead to tennis ball head. So what parts of our brain were changing and developing that caused this change of shape, and what can that tell us about our evolution? Let's look at two brains, two endocasts from our evolutionary history, one from 300,000 years ago, Jebel Ehud, and a modern human. These brains are roughly the same capacity. There's not much difference in size, but they have been reorganized. They have changed shape. So what parts grew and developed, and what can we deduce from that?
Two features of this process stand out: parietal and cerebellar bulging. Parietal areas are involved in orientation, attention, perception of stimuli, sensory motor transformations underlying planning, visuospatial integration, imagery, self-awareness, working and long-term memory, numerical processing, and tool use. The cerebellum is associated not only with motor-related functions like the coordination of movements and balance, but also with spatial processing, working memory, language, social cognition, and affective processing.
Clearly there was an evolutionary pressure, an evolutionary advantage in increasing our creativity, increasing our perceptions, increasing our adaptability. This might seem an obvious thing to say considering the vast amount of creativity we're surrounded by every day, like this wonderful YouTube video, the highest form of art. Ooh, I'm an artist. It is really interesting to think about this brain development, though. This progression from egghead to golf ball head over the past 300,000 years is mirrored in the archaeological record by an increase in creativity, by an increase in the sophistication of tools. The people living in Jebel Uhud 300,000 years ago probably didn't have no creativity, no symbolic expression, because we see, engravings and shells from 500,000 years ago that were created by Homo erectus. It's not much, but it shows that these archaic humans, there was something going on up there. There was a spark. There was a creative spark. By 100,000 years ago, we're starting to see much more rounder skulls in the archaeological record, and we see the development of really specialized bone tools like this harpoon from the Congo. We see in South Africa real great evidence for art and symbolic expression from ochre and carved ostrich eggs and jewelry made from shells. Moving forward in time by 50,000, 40,000, 30,000 years ago, this globular brain shape is, other than a few outliers, absolutely ubiquitous across Homo sapiens, and the evidence for symbolic expression and specialized tools is overwhelming. No one could look at the art from this time period and think that these were just simple cavemen. Nothing could be further from the truth. No archaic human ever quite reached the level of creativity and symbolism that we see produced by modern humans. Even though our opinion of Neanderthals has changed dramatically over the past 30 years, they were very intelligent, very sentient humans, truly humans. Yet they did not have this globular brain shape, and they didn't have as well a developed artistic expression. So even though our brains didn't really increase in size, this reorganization seems to have been absolutely key to our development. I am a globby globby head artist. That's what humans are, man. We're globby artists. The genetic evidence for our evolution in Africa is overwhelming. It's almost undeniable. Obviously, everything is subject to change, but this evidence is really overwhelming. It has to be said. African populations have a higher genetic diversity than anywhere else in the world. And the further you move away from Africa, the more that genetic diversity declines. Now, I don't want you to get offended or get hurt or get worried. I'm not accusing everyone outside of Africa of being one giant Habsburg dynasty. There's plenty of genetic diversity to go around. But this does illustrate that Africa is almost certainly the place that we evolved in. In biology, this is called the serial founder effect. If you had a region where a species evolved, that region is going to contain the entire genetic diversity of that species. If one group breaks off and moves into a new region, then that new region can only contain the diversity of the group that split. This is the pattern that we see in the archaeological record. Africa, high diversity. Outside of Africa, lower diversity. We don't just use this serial founder effect to discuss our movement outside of Africa. It's a really key tool that anthropologists and geneticists can use to trace human migrations. Let's look at mitochondrial haplogroup L3. A haplogroup is basically a line of descent, a lineage that you can trace back to one person deep in prehistory. So mitochondrial haplogroup L3 are the living descendants of this L3 woman who lived way back in time. The L3 haplogroup is found widely across sub-Saharan Africa. And interestingly to this whole debate, it is the haplogroup that every ancient fossil that we have DNA from outside of Africa descended from, and it is the haplogroup that every non-African haplogroup descends from. Let me repeat that. That's worth repeating. Every mitochondrial haplogroup outside of Africa descends from L3. Every single one. If you are not an African, you are a descendant of this L3 woman who was almost certainly African. No ifs, no buts, no coconuts. From Australia to Aberdeen and everywhere in between, you are a descendant of this L3 woman. And even if you are from Africa, there is also a very strong chance that you are a descendant of this woman too. Stefan from the future here, quick interruption. I shouldn't have said no coconuts. There are always coconuts with these things. Our evolution, our history is not straightforward. In this particular situation, the coconut is not whether you are related to L3 woman, but the coconut is whether L3 woman did live in Africa. There is some debate as to whether humans had already left that Africa by that point and were in Western Asia or maybe even South Asia, India. If that is the case, if L3 woman had already left Africa, that wouldn't negate the fact that we had evolved there. It would just mean that we had left earlier than we currently realize. There's always coconuts. I shouldn't have said that. There are always coconuts. Now, mitochondrial DNA is just a very small part of our entire genetic makeup, but this has been confirmed time and time again. In 2016, a study combined literally hundreds of genetic tests to create a phylogenetic relationship of humanity. The pattern is the same, guys. Africa is at the core of our DNA. If that wasn't enough, we don't just see this pattern in our genetics, we also see it in the genetics of bacteria that live within us. Helicobacter pylori, I think that's how you say it, is a bacteria that lives within our guts and causes stomach cancer and ulcers and stuff like that. It's really an absolute bastard, but nevertheless lives within us. We see the same pattern of genetic diversity. Helicobacter in Africa, high diversity. Outside of Africa, low diversity. This suggests that this bacteria was present in the Homo sapiens that first left Africa and as a result suffered a loss of genetic diversity just as us Homo sapiens did. Which is really fascinating. If you are suffering from stomach cancer, I am sorry. I truly wish you a speedy and painless recovery. But it is genuinely interesting that we can learn about our evolution from that. That is crazy to me. So as it stands at the minute, the earliest fossils that we could describe as Homo sapiens, archaic Homo sapiens, come from Africa, and the genetic evidence overwhelmingly suggests we evolved in Africa. That's a huge region though. Can we narrow it down further? Is there one specific place in Africa that we evolved in? That is a highly debated topic. If we look at the fossils that we've already mentioned, Jebel Uhud, Herto, Omo, Kafza, plus a few others, Florisbad in South Africa, Lake Tolly in Tanzania, Gombe in Kenya, there is a huge pan-African distribution of these alleged Homo sapiens. I say alleged because not everyone agrees on their classification, but these are basically the contenders for archaic Homo sapiens. The only region where it seems like there's a bit of a gap is West Africa, but that is the least well explored archaeologically, so it is quite likely that that is just a bias in the archaeological record. Either way though, north to south, there is a huge distribution of these archaic Homo sapiens. Considering this distribution, it might really be hard to find one particular point that we evolved in. This is the same in the genetic record. Different studies have come to different conclusions about whether South Africa or East Africa or West Africa or Central Africa were the original home place of our species. But again, it's just hard to untangle the genetic relationships between these groups that are constantly mixing. I explained earlier that a haplogroup is a line of descent from one person in prehistory. Well, we can push that to its logical conclusion, its extreme conclusion, and discuss the two people that every human on the entire planet is descended from. We call them mitochondrial Eve and Y-chromosomal Adam. These hypothetical people lived around 200,000 years ago. Let's say we found the region that they lived in. That's not necessarily the birthplace of all of humanity. These are just two people whose genetics, by probably absolute chance, have survived until the present day. It's not necessarily the first Homo sapiens. Where they lived is not necessarily the home region of our species. So to summarize, even though anthropologists and archaeologists are very confident that we evolved in Africa, what we mean by that and exactly how that evolution took place is still quite obscure and very highly debated. It does beg one massive question though. If we evolved in Africa, when did we leave? 60-ish thousand years ago. If you're not African, that's when your ancestors left the continent. This estimate isn't based on archaeological evidence though, really. It's based more on genetics. Remember mitochondrial haplogroup L3? That branch of our family tree, that lineage, formed around 60,000 years ago, or between 59 and 79,000 years ago, and puts an upper limit on our migration out of Africa. Certainly, our ancestors, your ancestors, did not leave that continent before 79,000 years ago. That stomach bug I mentioned earlier, that divergence in their genetics occurred around 58,000 years ago, and other genetic studies have put a migration out of Africa at around 55,000 years ago. So multiple genetic studies are all converging around roughly similar dates, let's say between 55 and 70,000 years ago. Our ancestors left Africa. This is great. This is all fantastic evidence, of course. There's one small problem, though. Archaeologically, we seem to have evidence of Homo sapiens outside of Africa much, much earlier than that. As I mentioned earlier, we know Homo sapiens were living in the Levant between 90 and 120,000 years ago. And a new study, hot off the presses, just released, has shown that there were multiple migrations into Western Asia within the last 400,000 years. This region is right next door to Africa, though. It's just a short hop, skip, and a jump. In the north, it is connected to the continent, and in the south, the strait between Asia and Africa would have been only between sort of 4 and 15 kilometers wide in prehistory. You could see Asia just over the shore. You could swim it, probably, if you're a good swimmer. So really, this southwest region of Asia was home to many hominins, many humans, many Homo sapiens during our evolution. Now it is very dry, very deserty, but there were lakes and rivers in this region periodically, and it's only natural to believe that humans just were following their climate, following the resources they needed, following the food that they needed, and spent long periods of our evolution in Western Asia. However, Western Asia is not the only region that we find very early Homo sapiens remains. Archaeologists found a Homo sapiens cranium from Apodema cave in Greece, which dates to around 230,000 years ago. Homo sapiens teeth have been found in China that date to between 80 and 113,000 years ago. We were in Sumatra by 70,000 years ago, and the north coast of Australia by 65,000 years ago. Those last two are within the sort of window of out of Africa suggested by our genetics, but they're right at the top end of it. We really would have had to have dashed along the south coast of Asia to get there by those times, which is possible. But still, we have those remains in Greece, we have those remains in China, we have a lot of hominin tools in India that we haven't been able to pin on someone. So how do we reconcile the tension between the genetic evidence and the archaeological evidence? The first possibility is that we have missed the genetic signals of these earlier migrations. In 2016, geneticists reported a previously undetected genetic signal in the genes of people in Papua New Guinea that suggested that they had a contribution to their DNA of Homo sapiens around 120,000 years ago. It was just a tiny fraction of their DNA, around 2%, so they are certainly still predominantly relatives of that later migration out of Africa. But it is possible that we have missed these earlier genetic signals of an earlier migration. However, other studies, knowing that geneticists had come to this result, tried to replicate it, and so far have been unsuccessful. So at the minute, it's really up for debate. It hasn't been proved at the minute that we have this genetic signal within us from an earlier migration out of Africa. The other explanation, therefore, is that these earlier migrations of Homo sapiens out of Africa have not left a lasting genetic legacy. They weren't really our direct ancestors. They weren't ultimately successful, you could say. This raises a lot of questions. If Homo sapiens expanded out of Africa but died out before this later migration at 65,000 years ago, why did they die out and other archaic humans like Neanderthals and Denisovans survived? If these communities of Homo sapiens survived until this later migration, then why don't we see more evidence of interbreeding between these two lineages of ours, especially considering the abundant evidence we have for interbreeding with other archaic humans? You know, that does raise questions. If they survived until that point, that is an interesting question. We know from studying archaic DNA within Europe and early European fossils that we are not really a close relative to the first Europeans anymore, that there has been a lot of population turnover. So these things are possible. It is certainly possible that these earlier migrations died out. Whatever caused that expansion of Homo sapiens between 55 and 70,000 years ago to be successful, it's clear we absolutely burst onto the scene. We kicked the door in and we rampaged around the world like an invasive species. We reached Australia by 65,000 years ago, Europe by 47,000 years ago, the far northern coast of Eurasia by 45,000 years ago, North America by 24,000 years ago, maybe even earlier, highly debated. Everywhere we went, populations of large animals seemed to die out soon after. We absolutely went wild, there's no question about it. What gave us that killer edge? What allowed us to expand like that at the expense of everyone else and to be so much more successful than any other archaic human, any other earlier migration of Homo sapiens? It could have been our technology.
One reason why humans failed to settle more permanently might be competition. Perhaps the presence of Neanderthals and other human populations in number was a key reason behind this. I think this might be one factor, but not the single explanation. I think it is more likely that before dispersing into the wide range of environments in Eurasia, Homo sapiens had first to develop a gamut of new and improved technologies in order to survive and prosper.
48,000 years ago in what is now southwest Sri Lanka, a group of Homo sapiens called this dense rainforest home. The rainforest really is a very different environment to the grasslands of Africa that we seemingly evolved in. Even though it's very green, very lush, it's not an easy environment to survive in. But nevertheless, this group adapted. Archaeologists have found a trove of arrows made from the bones of monkeys that these prehistoric Homo sapiens left behind. One of the arrows even has lines engraved on it which ethnographically other hunter-gatherers have used to attach poisons to arrows. It's possible that some of these other bones were used as darts. That's another possibility. Technology like the bow and arrow must have been a very important part of their survival strategy. It's very hard to hunt the small and agile game that live in the rainforest, live in the canopy of the jungle, without these quick, fast weapons. The earliest evidence we see of bows and arrows in the archaeological record come from Africa, interestingly, between 60 and 70,000 years ago, right on the cusp of our migration. It's fascinating to me that this community of hunter-gatherers in the rainforest, hunting monkeys with their bows and arrows, were contemporaries of the humans that were living in the far north of Siberia, the far north of Eurasia, who were hunting mammoths and huge game like that and living in a wildly different environment. These two groups of Homo sapiens were closely related. Their ancestors had left Africa maybe only 15,000 years before. Yet one group went north and adapted to the cold, one group hugged the south coast of Asia, adapted to the rainforest. This level of flexibility is only seen in modern humans, not in any other archaic human. Not in archaic Homo sapiens, not in Neanderthals, not in Denisovans. They adapted by following their preferred environment as the climate changed around them. This later migration of Homo sapiens was able to adapt by changing their lifestyle. In times of climatic variability, we were still able to expand. They contracted. We don't see any evidence of Neanderthals or anyone else producing technology like bows and arrows, atlatls, blowguns. They just seemingly did not produce them. This is honestly my 7th or 8th attempt at ending this video, because I feel like I should say something profound about our evolutionary journey, but I just don't know what to say. I don't know what profound thing to say. It's so hard because at the point we're at in this video, where I'm sat on this log right here, is about 30,000 years ago. Humans, Homo sapiens, have spread across the entire planet. All our archaic cousins have either been absorbed into our communities or are dead. After 30,000 years ago, it just seems like they're no more. And yet, even though we've been on this journey for 1 million years by this point, this is the start of human history. What we consider like the Upper Paleolithic, the Mesolithic, the Neolithic, on and on and on through time. The video ends at the point where all of human history kind of starts, so I don't know what to say. I don't know what profound thing to say, so I'm going to steal that quote from Winston Churchill. This is not the end. It's not even the beginning of the end, but it is the end of the beginning. Thanks for watching, guys. Loads more videos on human evolution, prehistory, our story to come. There's so much more to say, and I appreciate you watching.